Hi, today we're going to do number 347, top k frequent elements. So we're given an integer array nums and an integer k. Return the k most frequent elements. They can be returned in any order. So we can see in this example 1, 1, 1, 2, 2, 3, k equals 2. So the top two most frequent elements are 1 and 2 because 1 occurs 3 times and 2 occurs 2 times. So how can we solve this problem? One way we can solve this is to sort it. And with that, it will help us figure out what values are the most common. So what we can do is that we can create a, let me label it for sorting. So we create a frequency object. And we can see here like 1 occurs 3 times, 2 occurs 2 times, 3 occurs 1 times. And then with this, we can sort by frequencies and then get we can slice it, get the first k amount. And with that, the time complexity is going to be O of n log n, since we're looping through to create this frequency object and then sorting it, which is n log n, and then slicing it will also take up time up to O of k, I would guess, but O of n log n will be the most. The space complexity is going to be O of n, since we're creating this object, and the sorting method can take up to n space. But how else can we do this problem? Another way is we can use a min frequency heap. So with this way, we keep the same idea of creating this frequency object, but now we also create So how else can we solve this problem? Another data structure we can use is the min priority queue. And it's going to start off the same way. We create this frequency object, but then we create this queue. And then we push in queue the frequency object, values in the frequency object into it. So for example, we have this 2, and we use a min priority queue because we will have the 1, and then we'll have the 2, and then when it gets to 3, when it gets over the queue, it will remove the smallest frequency. And the key here is that we sort this min priority queue by the value of this frequency object, and that's what we'll get the answer. So if size of min pq is greater than k, we dequeue. And with the min priority queue, the smallest value will automatically be removed. Now we just create a res array to hold the return value, loop through min priority queue, and then push the number to the res and just return res. Because in the queue, we're going to hold, because this frequency object has the number in the count, and this number is what we're going to push to the res. The time complexity here it's going to be O of n log k, since we're looping through n, this length, and doing a log k to insert, because doing log k as we're inserting it to the min queue, min priority queue. And then the space complexity is going to be O of n plus k, since we're creating a object for the length of the priority queue of the input, and also k because our min priority queue can be up to k length. There's another way we can make it even faster, and that's using buckets. And the key here is knowing that we're bounded by the length of this nums array to know the frequency of each value. And we can use the index to know the frequency. And here we start off the same thing. We create this frequency array, but then we create a array that is the length of nums plus 1 to get out because it counts out 0 with empty arrays as values. So here we'll create an empty array with arrays, and what we're going to do here is that we loop through frequency object, and then for the frequency value we push the number to it. So and it could handle duplicates too by keeping it as an array. So we kind of flip this frequency object backwards by like, so this is 1, I have a count of 3. We see that the third index has a 1 inside of it. And now we need to create this res of what we're going to return. And then loop backwards from frequency, since we want to, since the most common will be at the end. And then just do it, push numbers to res until k is equal to the length of res. And here we can make it the time complexity return res. It's going to be only O of n, since we're just looping through the object, looping through the array, and then the space complexity will also be O of n, since we're creating this object, but it depends on the length of the input, and this array length also depends on the length of the input. And since this bucket way has the best time and space complexity, we'll go with this way, but we can do all the different ways. So here we do frequency, so const frequency equals an empty object, and then we loop through nums. And we check if it exists. So if it doesn't exist, we initialize it to 0. After that, we add a 1 to it. Now that our frequency is done, we create the bucket. So const bucket equals new array of length nums dot length plus 1 dot fill, which will be a dot map to an empty array. And now we can just loop through the frequency for const num in frequency. We can get the count. And now we find the index value. So bucket dot count dot push, and we can push this num so we know, and we have to convert it to a number. Now we do this backwards loop. First we create the res, and we're going to return it. We backwards loop through the bucket. And since each bucket has another array into it, we do another for loop const. And with this, we can push to the res. Let's push num, and then we check if res.length is equal to k. We returned res. Great. So now we can do the min priority queue. So we're going to keep this logic the same with this frequency array, and also keep the res. But now we create this new priority queue. So our heap was new min priority queue. And then the trick here is that, we want to look at the second value here. So we do x over 1, look at the first index. So now we have that. Now we want to update our values to this. So for const num in frequency, count, and then we do heap dot push, not in push, in queue, the num, and then the count that we're going to be comparing. And here we can check if the size is greater than 2. Okay, if we heap dot dq. Great, and now we just loop through. Okay, so now we just do a for loop for k amount, so let I equals 0, I less than k, I plus plus. We dq the value const, and we can just get the first number equals heap dot dq, and then now we res dot push num. So we have to convert it to a number to prevent this error, since the keys are as strings. Great. And now we can do the last method of sorting. So it starts off the same. We'll redo the frequency. And now we just return we sort it by the values of the count going down. And then we slice it by up to k to get the first k ones. And then we have to map to just get the number. You have to put this in a number. Great. It's a sorting method where we get the frequency and sort by the count that has the most common, get the top ones, and just slice to get the top k amount. Or we can use a min priority queue, where in the min priority queue, we just keep the k most ones that we need. And if there's more of it, we just pop it out because it removes the smallest amount and we'll have the remaining, the most frequent amounts in our queue. Or we can use the buckets. And the key here is that we know that our frequency is capped by the length of nums. So we can use that as a way to keep count. So we create this frequency object and then we flip it the other way around where like the 3 count occurs for what numbers, maybe 1 and 2, and we have to have another array because there's a duplicate, and then we can loop backwards from this frequency array and push the values to res to get the k most common one. And that's all. Thank you.